All right, on to the next session. This one is Rados Gateway Object Versioning. I believe the blueprint owner in question was Mike Bryant. Mike, you around? Speak up on IRC.
Well, Mike wrote the blueprint, but Ehud is doing the implementation. So
Okay, well, even better. All right.
Yeah.
Yeah, well, with regard to the object versioning, been implementing it for a few months now. There have been some discussion internally and externally, and there is a wiki page that describes the design that we came up with. And basically, originally we looked at that feature. There were two different approaches that were previously implemented. One is the S3 Amazon object versioning, and there's a Swift object versioning, and both are quite distinct. And historically, when we implemented the feature, we made it pretty much agnostic in the actual RESTful API. So there was the internal implementation, the core functionality, and then there was the RESTful API. But in this specific feature, the Swift API and the S3 API are so different that we just chose one, and we went with the S3 one, and that's what I've been implementing ever since. So there were a few requirements that we needed to take care of because the S3 API is quite different than everything we do or we used to be doing up until now. So first of all, there's needs to be an ability to list objects and their corresponding versions. You need to obviously be able to read a specific object version and remove a specific object version. Now, one more thing that we want to avoid is to need to be required to access the bucket index for each object read, because if we do that, then the bucket index becomes a bottleneck, which we wanted to avoid. And now there is the entire S3 API that surrounds the object versioning. You create multiple versions, you remove a version, then it rolls back to the previous version. You delete an object that isn't being deleted, but there's an object deletion marker then there has been created, and then you can suspend versioning on a bucket, and once you do that, the versions still exist, but if you create new versions, new objects, the object will be created with what they call a null version. And if you remove it, a null version marker has been created. So everything had to be supported. So we did discuss this, how to tackle this, because especially the rolling back of objects to the previous versions was kind of didn't fit our current design, because we usually don't have a cross-object interaction, because basically what you need to do is have kind of a pointer to another object, and if you remove an object, you need to change the pointer and to set it on a different object. But what happens if one of the operations failed while we were doing it, how to handle it, and what if you have multiple operations coming in parallel to the same object. How would the architecture work with this? We ended up coming up with a solution that in which we have the bucket index serves as the decision maker. So whenever you create a versioned object, you first go to the bucket index and basically say, okay, I'm now creating this object, and the bucket index will make sure that everything is happening at the correct order, and provide a log for the Rails gateway to replay or to play. So basically you go to the object that now we call the OLH, the object logical head, which is kind of a like soft link, and say, okay, I'm about to change to make a change to this object, and then we go to the backend index and say, okay, now we create a new version of the object, and the backend index would say, okay, go to the OLH, and now we are at this specific version. Make sure that we are at this specific version before changing anything, and update the OLH and set it to point it at the object version that was just created. And basically that's how it works. So you create we go update the OLH at that point, and it might have been that at this point we go to the OLH and we see that the OLH is already at version 3 because there was a racing right, but everything fits nicely because at the end the bucket index is the one that decides on the versions. Now about the object versions themselves, these are basically regular objects that are just put in a namespace, so that there is some kind of a naming convention that adds a version to the object. So whenever there is a versioning turned on the bucket, and every object now is being created with some kind of a version instance appended to it. Internally, the Rails gateway had to be changed so that instead of just keeping a string for each object, we now hold a structure that contains the name and the object instance, and that had to change like all around. Okay, so
I have a quick question on the S3 versus Swift thing. So the S3 has a pretty, as I understand it, has a pretty rich API as far as listing versions and rolling back to versions and all that stuff.
Mm-hmm.
On the Swift side, it's like basically when you overwrite an object, it first copies it to a different container, and then that's it.
Yeah, that's about it. So it doesn't do much there.
Yeah. So it seems like there's no real value in like trying to support that because it's so basic and kind of silly, especially if we're supporting the S3.
Yeah, right. Yeah, I honestly don't see the value at this point in supporting it. Yeah. Like, it's more of what are the user's requirement, whether they need versioning. If you have the S3 one, then it kind of encapsulates everything you need. The Swift provides a specific API, like you need to list don't really remember how it looks like. Like you need to list a specific bucket maybe, or I might be mixing it up with a different feature. But yeah. So as long as I think that as long as we support the S3 API, then it gives enough functionality for users. We'll be able to provide or maybe extend our Swift API to support the S3 object versioning.
Semantics, right?
Yeah, S3. Yeah. So and there's not much difference. Right? You just add a field and say, okay, that's our object version that I want to read, and so it should work fine.
Okay. And I guess the second thing is in Swift it's used as it's sort of wrapped up in the way that you do the object retention and object expiration. The same thing happens on S3, right? So once you have object versions, then eventually you'll be able to define a policy that controls like how many of them you keep. Is that right?
I don't remember if you have something like that. I think it's more of like how long in
how
object.
long they stick.
Yeah. Okay. Yeah, and I think that's the fact that we are dealing with object versions here doesn't change much. It might add some complexity to the feature, but at the end the object the bucket lifecycle feature the way I see it, there should be some kind of an external agent that would handle everything, and probably using some logs that will generate. And so whether we deal with versioned objects or with regular objects, it's not going to change much. The fact that, by the way, when I say external agent, it doesn't mean that it's really an external agent. It's just a different thread, maybe that runs on the gateway.
Okay.
Yeah. No, I made some changes to the bucket index, though. Originally, the bucket index was just a list of a plain list of objects that existed on the bucket. Then at one point we added some logs into it, but all residing in different namespaces. Now, the thing was that for this specific feature, we needed to be able to list versions embedded in the object listing. So we needed to put in the list of objects in the same namespace, or the list of object versions in the same namespace where the regular object reside, which wasn't really hard, obviously, but there is a new notion now. Now there are two types of keys in the bucket index. Ones that are just being used as for object listing, and new keys that are used for actual object data. So for an object, for a versioned object, for each instance we'd have two entries, one for being listed, and one for its actual data. And the reason we have two is that the versioned objects need to be listed in order, or from the newest to the oldest. So we need to make sure that they are kind of sorted in the correct way, and there's a way to generate that. But that makes it us that we need to index them somehow. So we needed to create a second entry for each in order to be able to look them up. And so there's the listing index and the data index, and then there is the null versioned object, which is an object that's created on a bucket that has suspended versioning, and there is some solution for that, but what it means is that for buckets that first had objects created before there were versioning on the bucket turned on, and now we enabled versioning, we create we convert the old entries into new entries, and we mark that as such. So we put an entry where where we used to have the original key, we put an entry and saying this is not a key anymore. This is a new version. And then we turn it, we convert it into a new versioned object because we need to keep it sorted in reverse order. So that's about it, I think. Any questions?
So the branches in progress, what's the sort of status of where the implementation is at?
Yeah. Okay. So objects can be created with the S3 versioning API has been implemented. Versioning object versions can be created. The object versions are going to be listed the correct ordering. You can turn on and off or suspend and enable versions on the bucket. There are some bugs in that area, but it's mostly working correctly. You can remove versions and it'll roll back to the previous version, which kind of the main theme here mainly works, mostly works. What's missing is there's no two major things is there's no timing out of when we mark an OLH and say, okay, we are now about to modify it, and then later on, if we read the OLH, we need to look at it and see if there is some kind of an operation in progress. We need to go to the backend index and query it and potentially play the changes because the original client that made the changes might have crashed. So we do that, but we don't time out. We don't we need to make sure that if it's an old change, we remove it. So I didn't do that, and there's the whole multi-region, multi-zone stuff that I haven't looked at it yet. So
yeah.
Okay.
Okay.
Yeah.
It seems like the biggest thing in validating all this is going to be getting the a big set of tests added to S3 tests,
right?
Cover all the combinations of adding heads and removing heads and removing old versions and listing and making sure that it's all whatever.
Right. Yeah. this moment, I'm testing everything manually, but yeah, I need to create some kind of test suite. I created a new S3 client just for the sake of version because I wasn't very happy with the other clients. It's a Python client, pretty simple, reflects what Bodo provides. Mainly, you can do most of the basic things like create objects, remove objects, and list objects, create buckets, and do everything with enable versioning on a bucket, and listing versions and everything. Not sure if that's going to be as the base for a new test suite, or I'll be using the S3 test suite, the existing one.
Yeah.
The problem with the existing one is that it doesn't handle versioning nicely. So if you create a version bucket, it wouldn't know how to remove it because there might be some objects hiding there that are versioned, but that can probably be fixed easily. But in a more higher level, the question is whether to create how to create the to generate all those test cases, whether doing it again is some kind of a Python code, or doing it in the more higher level, or like, I don't know, creating scripts that run that run the new S3 client, or I'm not sure. Probably going with the S3 test is a way to go, though. So
yeah, okay.
Got another 3-4 minutes here if there's any other questions.
So for the next session is the RGW snapshots. Is Craig around? We originally wrote the original blueprint. I'm not sure it's gonna. I wonder if this was an old blueprint that got slotted in, or if he got.
Yeah, but we asked him to reopen it and rediscuss it, because he originally sent a pull request for a branch where he implemented
using the full snapshots, I think. But
yeah. And we wanted to discuss self-managed snapshots instead.
Yeah. Okay. Is he here though? Doesn't look like he's in Blue Jeans.
Doesn't look like it. It's not on Summit.
Well, just I guess a stupid question. Does it even make sense to have like a bucket snapshot concept if we're doing sort of fine-grained object versioning? Or would it make more sense to if there is like a idea of snapshotting the whole bucket, that it's integrated with the way that the versioning is happening?
Well,
they're sort of doing the same thing.
not quite. Well, snapshot can give you a specific view at one point of the bucket.
Yeah. Right.
Object versioning can give you at an object level, not at the entire bucket level.
Right.
One point where bucket snapshots may be useful is for doing point-in-time zone replication. So basically, you take a snapshot, or hopefully you'd be able to do it cross pools. But let's say that that problem has been solved. But So you take a snapshot and then point the sync agents at that snapshot and not at their running cluster. So this will give you a good approximation of a point in time. Still not quite, because we still not flash all the changes all the time. I think, but correctly. Let me think about it for a second.
Yeah, I mean, it seems like even then, if you say you did have the seek agent mirror a point in time view of the bucket, eventually you're going to want to go to the next snapshot, which means that you need to have like a log of what changed between those 2 points, which is kind of what the sync agent is doing already.
Yeah, it's doing that already. Just it'll constrain the diffs. So basically, currently, what happens is that if the sync agent is a bit behind, and there are newer objects, it might be that some of the objects will be really new and some will be much older, because these it hasn't gone through the cycle, and this is gonna kind of limit it to all the objects are not going to be newer than this point. Whether it's it has any value, I'm not 100% sure, but
yeah. I guess the thing that worries me is that Rados Gateway in general has this this basic behavior that the object isn't visible until you complete the put. And when you are mixing snapshots in, then you have objects that are half written before the snapshot, which I guess aren't part of the snapshot, so that's okay.
Well, it's not going to change much as far as you just say, just limit the changes that you're looking at. It'll make it so that you'll be able to have a consistent view at the zone when doing the replication. I'm not sure if that's what Craig had in mind when he thought about this feature. And I know that originally we thought about snapshots for using in buckets for implementing some kind of versioning, but that was long time ago, before Amazon had any versioning. And and
well,
yeah.
I mean, okay, so what are the use cases here? So for the blueprint that Craig did, he wants snapshots that are for the entire Rados Gateway cluster, not per bucket.
Right.
Controlled by the administrator, not the user.
But
the user should be able to use them.
Well, I don't see why not. Like, if the user can have some access to his objects a day ago, 2 days ago, that is actually kind of useful. Getting a view of.
So if we did this with the self-managed snaps, but it's leveraging the Rados snapshot stuff. When you take a cluster-wide snapshot or zone-wide snapshot, I guess. I guess the key is that it would work the same way that RBD does, where you'd send a notify to all of the gateways that says there's now this snapshot, and
Yeah,
start tagging all of your writes like so.
yeah. There's
Right.
no way around it. The problem is that we write on multiple pools,
Mm-hmm.
and that's kind of a problem. You need to be able to create some kind of snapshot per all pools, which I'm not sure if it's not something that.
It would probably be okay. So this is for admin, self-managed snaps, and granularity. So the first, yeah. Yeah. So if they're, I mean, right now the snap IDs are allocated on a per pool basis. So I think it just means that a logical snapshot, a logical zone snapshot, is actually a map of it's a pool to snap IDT.
Yeah, but you'll need to create all snap IDs on all pools, in, at a single point of time.
I mean, kind of. You would allocate all the snap IDs that you're going to use for the snapshot, and then you have to sort of tell the gateways to start using them all at once, right? So the snap ID doesn't mean anything until the client starts using it.
Right. You have one here.
So it's like so allocate snap IDs.
Yeah, so that would work basically.
That you are right. Snap as creating notify RGWs, and then completed or failed.
Right, and need to make sure there needs to be some kind of a two-phase here. And like, because what happens if a gateway just came up before, after these were allocated, but before everyone agreed on it, or
I guess the gateway would have to start listening to the notify thing before it read the metadata. So if when a race it started up at the same time, it would read the snap metadata, see it's creating, and so it would start using that. Those snap IDs.
Yeah, well, it's a solvable issue.
Yeah. Okay. And then it would just use that snap context or whatever the per pool one is for both the bucket and it just use it for everything.
Well, almost for everything. Not for the zone metadata, region metadata. I don't think that's something that should be snapshotted. Not shouldn't be bundled with well,
region
I'm not sure.
metadata or whatever.
Yeah. I'm not too sure, because you might do need to bundle it together, because part of the information about the zone is like where to locate where the which
yeah, I mean that's probably where the zone would be, or the snapshot metadata would be stored, right, in the zone metadata. Region, whatever, region zone metadata. Makes sense, I guess. Okay, so that makes sense for all of the objects that are where you're striping out the restful objects on top of, and for the head object. for the bucket index, there's a bunch of stuff that you do on the bucket index that's asynchronous that you clean up later, like if you have a put that failed, it'll appear in the listing, but the object might not be there.
Yeah, well,
I guess those all get verified at the time.
Yeah, you look at it later on. If the bucket is listed later on, there is some kind of a pending entry there, then right. So
then you would have to validate when you actually do the listing, and there's a pending thing. You actually go check the object, right, to see if it's there.
Right, but
okay.
You'll need to disable all those things for because then you go and update the bucket index, and you don't want to go update the bucket index when you're in a snapshot.
Right. Okay. So, yeah.
Another thing that you don't want to snapshot, by the way, is the garbage collection.
Yeah. So that wouldn't be snapshot. Is that in the same pool as as all the other stuff?
No, it's a different pool.
Different pool. Okay. And then RGW, it would just take like another header that says view this particular snapshot.
Yeah.
I guess.
Yeah. Mm-hmm.
And it would have a name, the snapshot at times created.
Yeah, and there's probably going to be an API to list the snapshots. So.
Okay. That seems pretty reasonable, actually.
Yeah.
Why did we think it was really complicated before? I think we're trying to do per bucket ones, maybe.
I don't think we really did want to do anything. Like, yeah, at the time we spoke about per bucket for implementing versioning and doing all sorts of crazy stuff, but it wouldn't have scaled. But if you take the global approach, then
yeah. Yeah. Okay. Okay.
Right.
Sounds very reasonable.
Yeah. Any question from anyone?
People who are clamoring for RGW snapshots, or have a particular use case in mind besides? I think Craig runs he's running a multi-site cluster, right? Multi-region.
Yeah. Yeah, he does.
Yeah. Yeah. Okay. Yeah. Okay.
Well, we can talk about bucket lifecycle. I don't think we have a slot for that.
Yeah. Yeah. Okay. Let's do that. This is coming after object versioning, probably.
Yeah, that's coming after object versioning, and sadly, we didn't really think about it much. But that's one of those features. It's kind of like object versioning in terms of Swift versus S3, where Swift taken one approach, S3 has taken a completely different approach, and we're tending to go with a S3 solution, which is much more complicated. So first, the Swift approach is basically doing it per object expiration. Every object that's been created with an with an expires tag, I think, or I don't really remember how you set it up, but you can control per object expiration, and then there is some kind of an async process that goes and look at the objects that need to be expired, and it sends them to the trash or something like that. And probably object that has been expired and you try to read them, it either succeeds or not succeed, but there's some kind of logic there. With regard to S3 bucket lifecycle, that's how it's called. You do it per bucket. So you say, okay, on this bucket, all objects will be expired after this amount of time, or all the objects that correspond to this filter, all objects that start with the letter A can be expired, or will be expired, or will be deleted, but the bucket is version, so the version is going to be created for them, or they're going to be transitioned into a secondary storage. But that's a per bucket, so there needs to be some kind of a whole bucket process, something that looks at the bucket and knows how to do those things on the entire bucket, and to add some complexity, you can turn it off and on again, and once you turn it off, it shouldn't work, and if you turn it on or put a new configuration, then the new stuff needs to work, while you don't need to make sure that the old stuff is not happening. And you can have, I think, multiple policies on a bucket. So yeah, so it sounds like a great fun.
Yes. When the transition to secondary storage, that's the idea that after a bucket is deleted, or if it gets old, then it's moved into a different bucket. That's, for example, reduced redundancy. That's the idea.
I'm not sure if it's a different bucket. I think it is a different bucket.
Okay.
But yeah, it's either reduced redundancy, or Amazon has that Glacier. Amazon Glacier, you move it to some deep freeze. Much cheaper storage.
And at the point at which that happens, it's no longer in the same bucket, right? It's not like you have a single object in a bucket that's backed by Glacier.
Yeah, I think it moves to a different bucket.
Okay.
I'm not 100% sure about that though. I need to check that.
Okay.
It will be impossible for us to implement something that's not moving it to a different bucket. Or maybe not, because now we have the OLH. So
yeah. That'll be more complicated that way. Okay. For that, I wonder if a low-hanging fruit for even for hammer time frame is just the wiring up the reduced redundancy S3 APIs, so that we can already obviously have multiple Rados pools that back the zone, and you can select which one. Sort of, I guess similar to the what is Ceph calling storage policies. But we could map the reduced redundancy one to a specific Rados pool or whatever to provide that same API.
Yeah, we at the moment you can already create multiple bucket placements or pools placement. I don't remember what it's called. and you can create a bucket in a specific with a specific placement target using the S3 API. We have a way to specify it, but it's not the reduced redundancy API. It's just like we say, it's depending on how the admin named the bucket placement target. But yeah, we can wire it up to the reduced redundancy API and should just work. So it's really not a big feature. We can probably do it. We should do it.
Are there any other basic functionality that the Swift storage policies are trying to capture that we can do at the same time? I don't know what the actual API looks like for. They just they just have names. You have like the gold policy, the silver policy.
Well,
that's basically what we already do, right?
We already do that.
Okay.
And we can have a way to. We already have that. Like we have a way to have a user on the gold policy and a user on the silver policy, so that each user buckets will be created in a different policy, and you can limit a user to only use specific policies. So we already have that. Maybe what we're missing is documentation. That's
probably
yeah. That's something that we can improve on. I sent at the time I sent a few emails. There were questions. So I explained how to use it, but it'll be better served as a part of the Ceph documentation.
The thing that somebody could probably pretty easily do is just take the current. I'm just skimming the Swift docs, but they just added a new header called X storage policy with the name. We just wire that header up to use our current thing because we're using a different header presumably.
Well, currently we don't use a header. It's part of when you create the bucket. It's part of the bucket request. There's some kind of but yeah, we can wire that to the bucket placement target, and it will just work. For the reduced redundancy, we need to make it so that if you specify reduced redundancy, you'll go to a specific.
Just pick one.
Yeah, just pick one. So we need to define it somehow nicely and say which one is the reduced redundancy.
Yeah. Okay. Okay, that seems pretty easy. And then, and that could be different erasure code, or it could be 2x replication, or it could be whatever we do on the back end.
Yeah. Well, that depends. Really depends on the admin.
Documentation would be good. Half the stuff is already there. Okay.
We're gonna move on a little early.
We might as well. So we're not. Guang can't make it either, right?
I know. I just realized that. Let me kill this recording.